Okay, welcome everybody. This is a run through of your chemistry year 10 assessment. It's really important that you get a green pen and that you correct your answers and improve your answers. There were many really silly mistakes that can be easily corrected, and there's lots of extra marks you can get if you work through this video and you correct your work as you go along. Okay, question number 1. It says, when copper sulfate solution reacts with sodium hydroxide solution, a precipitate of copper hydroxide and a solution of sodium sulfate are formed. It then gives you an equation given the formulas of all of those things that it's mentioned. Now, it says the formula of a sodium ion is Na+. What is the formula of a sulfate ion? Well, in order to answer that, you need to see that you should know the formula of a sulfate ion anyway, but sulfate goes around with sodium and it goes around with 2 sodiums. So sulfate is sulfur with oxygen. That's what the 8-bit means. It's sulfur with oxygen, and sulfur goes around with 4 oxygens. So sulfate is SO4. Now, the fact that it goes around with 2 sodiums, and it gives you in the question sodium is Na+, that means the charge on a sulfate ion must be 2- because it goes around with 2 positive charges. So the answer is D, SO4 2-. Okay, part B says 10 centimetre cube samples of copper sulfate solution were placed in 5 test tubes. Different volumes of sodium hydroxide solutions were added to these test tubes. The volumes of sodium hydroxide solution added were 1 centimetre cubed, 2 centimetres cubed, 3 centimetres cubed, 4 centimetres cubed and 5 centimetres cubed. In each test tube, a precipitate of copper hydroxide was formed. The precipitate was allowed to settle and the height of the precipitate was measured with a ruler as shown in figure 1. It then says the results are shown in figure 2, and the first thing that it asks you to do is to draw a line of best fit through that data. Now, a line of best fit, it can be a curve, but in this case it's a straight line, and when you draw your straight line you need a pencil and a ruler, and you need to draw the line through as many points as possible. Now, where it can't go through all the points, you need to make sure that you've got as many points above the line as you have got below the line. So I think the 3 points in the middle are in a perfect straight line, and I'm going to draw my line through those points, and that means it doesn't go through 2 of the points, and I've got 1 point above the line and 1 point below the line. So if you did that, you got 1 mark. Now, the second part, it says, what is the height of precipitate formed with 6 centimetres cubed of sodium hydroxide? Now, the first mark was for extending your line of best fit out so it goes to 6 centimetres. So if your line went that far, you got 1 mark. And then you had to read off the height when it was 6 centimetres cubed, which the best way is to draw these 2 lines on there and there. And then you have to read off that value on the y-axis. Now, lots of people have problems with this y-axis. There are 1, 2, 3, 4, 5 squares and 2 numbers, which means that each little square is 0.4 millimeters. So this becomes 2 little squares above 14, which is 14.8. Now, it didn't matter what value you got, but you had to read it accurately off the graph, which lots of people failed to. So the answer in there is 14.8. Okay, the next part of the question says the copper sulfate solution has been prepared by dissolving 6.36 grams of solid copper sulfate in water and making the volume up to 250 centimetres cubed. Calculate the concentration of the copper sulfate solution in grams per decimeter cubed. Well, and then it says give your answer to 3 significant figures, and I'm just going to underline that to remind me. Now, I've got the grams, and I need to divide that by the decimeter cubed to get grams per decimeter cubed. The concentration is the number of grams divided by the volume in decimeters cubed. The problem here is that I've got a volume but in centimeters cubed. So the first thing I need to do is convert the volume into decimeters cubed, and there are 1,000 centimeters cubed in 1 decimeter cubed. Therefore I need to divide 250 divided by 1,000 equals 0.25 decimeters cubed. So I've got a quarter of a decimeter cubed. 250 centimeters cubed is a quarter, 0.25 decimeter cubed. I then divide my grams, so 6.36 divided by my decimeter cubed divided by 0.25 gives me a calculated value of 25.44 grams per decimeter cubed, and I've got to remember that the final value is to 3 significant figures, and so that is 25.4 grams per decimeter cubed to 3 significant figures. The final part of the question says copper ions Cu2+ react with hydroxide ions to form copper hydroxide. Write an ionic equation for this reaction. Those of you that are eagle-eyed notice that the formula for copper hydroxide was actually given on page 1, or the first part of the question, but we can work it out anyway. Now, the knowledge that you need to know, it gives you the formula of copper ions, but you need the formula of hydroxide ions, and hydroxide are OH1-, which you should know. It's one of the complex ions that you should learn. And that means that when I make copper hydroxide, I need 2 hydroxides to every copper ion, because copper hydroxide has got to be neutral. Copper is 2+ and hydroxide is 1-. Therefore, I need 2 hydroxides to every copper. So the formula of copper oxide becomes CuOH, and then I need 2 of them. So it's CuOH2, which that was given in the question earlier on, but you can work it out anyway. Now, when I form a precipitate, the ions come together to give the precipitate, and the ionic equation for a precipitation reaction is just the ions reacting to make the precipitate. So you got 1 mark if you wrote down the correct ions and the correct formula of the precipitate. So that's Cu2+ plus OH- goes to give CuOH twice. If you wrote that, you got 1 mark out of 2, but you needed to balance it correctly, and you need 2 OH- ions to form that, and that will give you the 2 marks. Okay, question number 2 says, some food colourings are a mixture of soluble coloured substances. Mixtures of soluble substances can be separated by paper chromatography. Paper chromatography was used to try to separate the coloured substances in 5 food colourings, V, W, X, Y and Z. Figure 3 shows the spots for the 5 food colourings on the chromatography paper at the start of the experiment. The paper was placed in a beaker with the bottom of the paper in the solvent. Part 1, it says identify the stationary phase in this experiment. Well, in paper chromatography, the stationary phase is a thing that stays still, which is the paper, and the mobile phase is a thing that moves, which is the solvent. So the stationary phase is the paper. And part 2, give a reason why the spots in the food colouring must be above the level of the solvent when the paper is placed in the solvent. If they weren't above the solvent, they would wash out or dissolve or mix with the solvent. So they would otherwise would dissolve in the solvent. Part 3 says figure 4 shows the chromatogram at the end of the experiment. Give the reason why the spot of food colouring V has not moved during the chromatography experiment. And the reason why V hasn't moved is that it's not soluble in the solvent. So the answer is V is not soluble in the solvent. And the answer isn't that V only contains one type of substance. If it did, it would have one dot, but the dot would have moved up the paper. Part 4, explain by referring to figure 4 which food colouring contained the greatest number of soluble coloured substances. Well, the answer is Z, and you got 1 mark for writing Z, and that is because it had 4, or the most, 4 dots, which was the most. And you got the mark for saying it either had 4 or it had the most. The last part says one coloured substance is in food colouring X moved 5.8 centimetres when the solvent front moved 6.6 centimetres. Calculate the RF value for this substance, giving your answer to 2 significant figures. Well, the RF value is always a value between 0 and 1, which means that it's got to be the small number divided by the big number. So it's the distance that the dot moved divided by the distance that the solvent moved. So it's 5.8 divided by 6.6, which gives you a value of 0.8787, calculator value 0.8787, which if you're going to quote that to 2 significant figures, it's got to be 0.8, and then you're going to round the 7 up to an 8 because the next one is the 8, so it's 0.88 to 2 significant figures. Part B says a food colouring has the molecular formula C16H12N2O. Calculate the number of moles of this food colouring in a 0.5 gram sample. Well, the equation that you need is moles equals grams over RFM. The RFM is calculated by 16 carbons. Carbon weighs 12, so it's 16 times 12. I've got 12 hydrogen. Hydrogen weighs 1, so it's 12 times 1. I've got 2 nitrogens, and nitrogen weighs 14, so it's 2 times 14. And I've got 1 oxygen, so it's 1 times 16. If you do that calculation, you get 192, you get 12, you get 28, and you get 16. If you add all those together, you get 248. So the grams is 0.5 divided by 248, and that gives you a value of 0.002 moles, or 2 times 10 to the minus 3. It doesn't matter which you put in there, 0.002 moles, and that gets you 2 marks. Now, the second part says calculate the number of molecules in 2 moles of the food colouring. So instead of 0.002 moles, I've got 2 moles. Well, the Avogadro's number is the number of Avogadro equals the number of molecules or atoms, molecules per mole. So the way that I find the number of atoms or molecules is I times the number of moles by the Avogadro number. So it's simply 2 times 6.02 times 10 to the 23, which gives you a value of 1.2 times 10 to the 24. 1.2 times 10 to the power of 24. Question 3 says a carbon atom contains 6 electrons, 7 neutrons and 6 protons. State the mass number of this carbon atom. Well, the mass number is the number of neutrons and protons, because those are the two atoms that have mass, and 7 and 6 added together is 13. Give the electronic configuration of this carbon atom. Well, that's the number of electrons expressed in 288 form. So I've got 6 electrons, so I'm going to have 2 in the first shell and 4 in the second shell, so it's 2, 4. You can put it in square brackets if you want to. Diamond and graphite are both forms of carbon. In both substances, the carbon atoms are held together by covalent bonds. Describe what is meant by a covalent bond. Now, there are lots of good answers here about a covalent bond is a strong bond between non-metal atoms, which is all correct, but it's not the definition. The definition of a covalent bond is that it is a shared pair of electrons between two atoms, and that is all you need, a shared pair of electrons between two atoms. Now, many of you put that the electrons were shared, but you didn't put down that they were a pair. And if you put down shared electrons, but it is one covalent bond is one shared pair of electrons. So it's often drawn as a dot and a cross between two atoms. Hydrogen has each got 1 electron, and so that together, 2 electrons shared between the two, is a covalent bond. The next one, explain in terms of its structure how graphite conducts electricity. Well, the graphite is an allotrope of carbon. Carbon normally forms 4 bonds, but in graphite, each carbon forms 3 bonds, which means that it's got a spare electron, and that electron can move in between the layers, and because it can move, it can carry a charge, and therefore graphite conducts. Now, you had to say that graphite has electrons which can move between the layers and carry charge. Now, the charge carriers are electrons, so you've got 1 mark for electrons, and the fact that they can move, they're free electrons, they're delocalized electrons, is okay, but you had to say that it was electrons and that they could move. Part D says diamond and carbon dioxide are both covalent substances. Draw a dot-cross diagram to show the covalent bonding in a molecule of carbon dioxide. It's useful if you knew that carbon dioxide forms double bonds. If you don't, then you know that carbon has got 4 electrons in its outer shell, and you know that oxygen, so I could draw carbon with 4, and I know oxygen has got 6 electrons in its outer shell. Now, the question is, how can I combine those two together so it's as if they both have full outer shells? And the answer is I'm going to form 2 double bonds. I'm going to form a double bond. So the 2 from carbon are like that, and then the oxygens I'm going to draw as crosses are like that. Now that is a double bond, 2 covalent bonds. That means that oxygen, which I'm drawing as crosses, has got another 4 electrons. 1, 2, 3, 4, and oxygen here. 1, 2, 3, 4. Now, when you've done that, to check it, you need to check that each atom, using the other electrons for the other atom, has 8 electrons. It's as if each atom has 8 electrons in its outer shell. So if I look at this oxygen here, then it's got 1, 2, 3, 4, 5, 6 of its own electrons, but it's got 2 from carbon. The same with this oxygen here. And the carbon in the middle has 4 of its own electrons, but it's got 4 from the 2 oxygens. So it's as if carbon has 8 electrons. Okay, so when you draw a dot cross diagram, always check that you've drawn 8 electrons around each atom, 2 if it's hydrogen, just to check that it's as if they both have a full outer shell. The next one, diamond has a very high melting point. Explain why the melting point of diamond is very high. Well, every bond between carbon atoms is a covalent bond in diamond, and covalent bonds are strong and they require a large amount of heat energy to break or overcome. So in diamond, every bond is a strong covalent bond which require a large amount of heat or energy to break. Question 4 says magnesium has an atomic number of 12. Which line in the table shows the correct number of protons, neutrons, electrons in a positively charged magnesium ion? Well, magnesium is in group 2, so you could very quickly do 12 electrons, couldn't you? 1, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then that's 10, and then it's going to have 2 in its outer shell. Now it's going to form a 2 plus ion, Mg2 plus, because it's going to lose those 2 electrons. Now in Mg2 plus it's going to have 10 electrons, but it's going to have 12 protons. So if I look down, the one that's got 12 protons and 10 electrons, the only one that is D, and in fact that is the answer. Calcium oxide is an ionic solid. Figure 5 shows the arrangement of electrons in calcium atom and an oxygen atom. Complete figure 6 to show the electronic configuration and charges of the calcium ion and the oxide ion. Use dots to show the electrons originally in the calcium atom and crosses to show electrons originally in the oxygen atom. Well, a calcium ion is going to have lost these 2 electrons, and therefore it's going to have 8 electrons out here. That means that it's Ca2 plus. That is Ca2 plus, and so it's going to have a 2 plus charge because it's lost 2 electrons. Now those 2 electrons are going to join with oxygen, and they're going to make it have a full outer shell. So at the moment oxygen has got 1, 2, I'll draw it like this, 1, 2, 3, 4, 5, 6 electrons in its outer shell, and the 2 electrons from calcium are going to join the oxygen to give it a full outer shell. So it needs to be like that. And because my oxygen has gained 2 electrons, it gains a negative charge. So that will be a 2 minus. So that is the O2 minus ion. So I've got calcium 2 plus lost 2 electrons, O2 minus gained 2 electrons. Both calcium and oxygen now have a full outer shell of electrons. Part C says, in an experiment to determine the empirical formula of magnesium oxide, the mass of oxygen combined with a known mass of magnesium must be found. Describe an experiment to determine the mass of oxygen that combines with a known mass of magnesium in a crucible and lid of known mass. Well, you should have all done this experiment, and what you did was take the magnesium and put it in a weighed crucible with lid, but it says that already, be in a crucible and lid of no mass, a known mass of magnesium. You are then going to heat the magnesium strongly on a Bunsen burner. So you got 1 mark for saying heat the magnesium. So heat the magnesium strongly on a Bunsen burner. Ideally you want to heat it to a constant mass, but if you heat it strongly, after you've done that, you are then going to weigh now you've started off with magnesium, but it's turned into magnesium oxide, so you weigh the magnesium oxide crucible and lid. Now the key point there is that you can't just weigh the magnesium oxide because it's a powder and it's inside the crucible. So you need to weigh all three of those things again at the end of the experiment, and then you need to subtract the mass of magnesium crucible and lid to find mass of oxygen. Part D was a nice, really quite simple empirical formula calculation. It was found that aluminium was combined with chlorine, 0.27 grams of aluminium and 1.065 grams of chlorine. So I've got two elements. I've got aluminium, I've got chlorine. I'm going to lay it out where I do grams and then rams. So my grams of aluminium, 0.27. My grams of chlorine, 1.065. Grams over rams, 27 divided by 35.5. That gives me two numbers, which are 0.01, 0.01 and 0.03. So the ratio is 1 to 3. But importantly, the formula then is 3 Cls to every 1 Al. So I've got AlCl3. And that gives you 3 marks. Question 5. The atomic number of magnesium is 12. Magnesium exists as 3 isotopes: magnesium 24, magnesium 25 and magnesium 26. Describe, by referring to the number of subatomic particles, the differences between one atom of each of these isotopes. So I need to describe the number of subatomic particles in each of these. Well, they've all got 12 protons. So the way I'm going to do this is just Mg24, Mg25, Mg26. They've all got protons equals 12, protons equals 12, protons equals 12. They're all just magnesium atoms, so they're going to have 12 electrons. And the only difference then is the number of neutrons, and the number of neutrons is the mass number is the protons plus the neutrons. So 24 minus 12 equals 12, 25 minus 12 equals 13, 26 minus 12 equals 14. And that would get you the full 2 marks because I've said how many protons, neutrons, electrons there are in each one. You could also get the 2 marks if you said that magnesium 25 has 1 more neutron than magnesium 24, and magnesium 26 has 2 more neutrons than magnesium 24. If you just said that they had a different number of neutrons, then you only got 1 out of the 2 marks. Now, part B is the 6-mark question, and it says a sample of magnesium contains 79% magnesium 24, 10% magnesium 25 and 11% magnesium 26. In most calculations, the relative atomic mass of magnesium used is 24. Use this information to explain why, in this sample, magnesium has a relative atomic mass of 24.3. Well, the relative atomic mass is the mass, the mean weighted mass of an atom, which is the average mass of an atom taking into account the abundance of those atoms. Now, the way that it's calculated, it's the sum of the percentages of each isotope. So you got, the way that this question was marked, you got 3 marks for doing a calculation to prove that the relative atomic mass of that sample of magnesium was 24.3. So if you put down something like this, if you've got 79% of 24 plus 10% of 25 plus 11% of 26, which is the same as, 79 times 24 plus 10 times 25 plus 11 times 26 all over 100 equals 24.3. That got you 3 of the possible 6 marks because you've proved by calculation that the relative atomic mass of this magnesium is 24.3. Now, the other 3 marks were showing that you understood why 24.3 was the relative atomic mass and it's not 24. So you need to say the relative atomic mass takes into account the mass of isotopes and their abundance. This sample has much more magnesium that weighs 24, so the average mass is much nearer to 24. It then goes on to say in the mark scheme, magnesium 25 and magnesium 26 are heavier isotopes, but because there is little of them, the average mass is not increased much above 24. Now, if you said that, you've really shown that you know how you calculated the relative atomic mass and what it means. It's the average, the weighted mean mass, the average mass that is weighted to take into account the abundance of each of those isotopes. And you've got 3 different isotopes. You'd expect the average of 24, 25 and 26 to be 25. But because you've got much more 24 than you have 25 and 26, then the weighted mean is going to be much more nearer 24 than it is near 25 or 26. And it was showing that you had that understanding to get all 6 marks. The last part of the question says, in 1871, the Russian chemist Dmitry Mendeleev produced the first version of the periodic table. Describe how Mendeleev arranged the elements in this first version of the periodic table and why the elements are arranged differently in the modern periodic table. and it was 3 marks. You got 2 marks for saying how Mendeleev arranged his atoms. So Mendeleev arranged elements in increasing mass. So it allowed relative atomic mass, but it didn't allow mass number, because the mass number is the number of protons and neutrons, and he didn't know about protons and neutrons, so it's just got to be in terms of increasing mass. He also then did 2 things. He left gaps for elements that hadn't been discovered, and he also switched elements. He switched elements so they fitted properties in columns, so that their properties in the columns fitted. Now that's what Mendeleev did. The modern periodic table is arranged in terms of increasing atomic number. Modern periodic table equals increasing atomic number. So nowadays we know about protons and electrons, and we arrange atoms according to increasing number of protons, which is the atomic number.